we're going to continue looking at sequences, but some much harder versions. Okay, so let's just remind ourselves of the really simple version, right? Where we have a linear equation and we're going up by a standard amount. You can easily see that we're just adding 3 each time. And so the difference is just going to be a. So then the nth term is going to be 3n plus something or other. So then I just substitute in 1. So if the first term is 3 times 1 is 3, plus 1 is 4. And then you can just check. Let's check the fifth term. 3 times 5 is 15, plus 1 is 16. Great. All right, let's look at something that's a little bit trickier. So this one does not go up by a consistent amount. It goes up by 7, then it goes up by 11, then it goes up by, what's the next one going up by? 15, and then 19. So we're not going up by anything consistent that we can see. So what I'm going to do is I'm just going to put these numbers in here to show the difference between them. So I've probably written this diagram a bit terribly, but that's okay. So the difference between 0 and 7 is 7, and then 11, and then 15, and then 19. And then what I'm going to do is, let's pick another colour, I'm going to see the difference between this row. So the difference between these is 4, difference between these is 4 and 4. Great. So once I get to a point where I've got an even amount, it's going up by an even amount, then I know I'm done. So what I've done is I've gone 2 steps of difference. So this is a quadratic equation. So however many steps it takes you to get an even difference, that's the power that you're going to have. So in our case, we're going to have a squared term. Now, I can't just make some assumptions from this. I need to do some more information over here. So what I'm going to do is I'm going to write it out using some algebra. So I'm going to use, so what I'm going to say is if this is my rule, well, this is the rule I want to come up with, I'm just going to use some algebra and write them over here. So the first position is just going to be a plus b plus c, and then I'm going to make this one 4a plus 2b plus c, and then I'm going to, whoops, I don't really have enough room for this. I haven't left enough room, that's annoying. And then 9a plus 3b plus c, I'll talk you through this in a second. Then I'm going to have 16a plus 4b plus c, and then I'm going to have 25a plus 5b plus c. Now, hopefully you can tell what's going on here. All of these things are just 1, right? This is my 2, but this one's squared. This is 3, but this one's squared. 4, but this one's squared. And 5, but this one's squared. Okay, so I'm just putting in my, my a and my b numbers. So then what I'm going to do is I'm going to say that the difference between these two algebraically, so if I talk in terms of algebra, the difference between these two is 3a plus b, right? I'm basically just subtracting that from this. And then I'm going to do the same thing for the next one, 5a plus b, then I get 7a plus b, then I get 9a plus b. Okay, so I'm just taking this one and subtracting that one from it. So then what I'm going to do is now I'm going to look at the difference again between all of these sets. So the difference between these is just 2a. And the difference between these is just 2a. And the difference between these is just 2a. So now see how I've come to the exact difference. So the third row, just like before, so I had my numbers and then I had my things. So now I'm talking about what the actual difference is in terms of algebra. So this is where we want to match up these things. I know that 2a equals 4, right? Because all I did was talk about the same information algebraically. So if I know that 2a equals 4, well, I know that a equals 2, don't I? That's really good. So then what I can do is I can substitute that into one of my other equations to find out more information. So I had over here, what have I got? I've got 3a plus b, so let's take that. So 3a plus b, and I know that that equals 7, right? 3a plus b. So if we had a look before, we know that the first term is 7, and I know that a is 2, so 3 times 2 plus b equals 7. So then 6 plus b equals 7, so then b equals 1. Great. Now I can do the exact same thing again to work out c. See, I'm just reverse substituting. So now I might as well go back and use this one because it's the easiest. I use these three because they're the easiest. You could use any of them, but it's easier to use the three lowest ones. So then a plus b plus c equals 0. So a is 2, b is 1, and c is, we don't know. So 3 plus c equals 0. So then c must equal -3. So now that I have all of that information, I can put it together to form my equation. So the nth term, I know that a is 2, so I've got 2n squared, plus b is 1, so I just can write n, and c is -3. So that gives me my equation. Now I know this is a bit complicated. This is much harder than the previous stuff that we've done. But basically what you want to do is work out the difference between them, right? Which is what we did before. And then if they don't match, there's no consistent difference, find the difference between those. And once you've found it, great. Then we're just going to write it differently using this kind of idea. So this is the first term, second, third, fourth, fifth. So all of the first ones are ones. Then 2, 2 squared and 2. 3, 3 squared and 3, 4, 4 squared and 4, and so on. Then you work out the algebraic difference between them. It's this minus this. Then you work out the difference between these two, and then once you've got a common difference, then you start taking your substitution. You take this and you know that 2a is 4 because that's what we said that difference was. The difference between these is 4 and it's also 2a. Right, so I'm going to show you, unfortunately, an even harder version now. So now what we're going to do is look at one that is cubic. So this had a power of 2, and we're going to look at one with a power of 3. So what I'm going to do is I'm going to look at this set up here. Okay, so again, all I've done is write them out there, and we're going to work out the differences between them. Now, hopefully you can already tell that something is weird here because we've got two identical terms. And remember, I mean, it's possible to have two identical terms in this because if you remember, a quadratic graph looks like this. So you could have two equal values. We just didn't use the right values to get that. Here we do. So if you remember that a cubic graph looks like that, so you're going to have multiple values that are the same, and that's okay. So the first thing we're going to do is work out the difference between these terms. So the difference between -6 and -8 is -2. And then the difference between these two is going up by 2 this time. Difference between these two is 12. And then we have 28 between those. Okay, so nothing is in common yet. So difference between these. This time I'm going to say the difference is 4. The difference is 10. The difference is 16. Still nothing. I'm going to go another round. The difference between these is 6. Difference is 6. Fantastic. I have found my equal distance. So what I'm going to do is I'm going to use this idea here because this is the general form of any cubic equation. So I'm going to do the same thing I did before, but I'm going to have 4 terms this time, which means we need an extra row. It's going to become a little bit tricky. So the same thing is going to apply. I'm going to start with, and I way don't have enough space for this, a plus b plus c plus d, right? They're all ones. But because we're on the second term, what we're going to do now is start off with, so the first term is 2, but this time it's cubed, so 2 cubed is 8a, and then the second one has to be squared, so I get 4b. The third one is just normal, so I get 2c and then d. Same with this one. This is the third one, so 3 squared is 27, and then I should have 9 and 3 and just d. And then the fifth one, the fourth one, I don't want to skip one. The fourth one should be 64 because that is 4 cubed. And then 4 squared is 16. And then 4 and then d. And then my last one is going to be cubed. So I'm going to end up with 5 cubed, 125a plus 25b plus 5c plus d. All right, now I have not left enough room and that is super messy. You're going to do it better than me, but you get my point. Okay, so what I want to do is find out the algebraic difference. So I'm just going to do this minus this. And I'm just going to write it in a different color because I'm clearly not going to do it well enough. So 7a plus 3b plus c. And then the next difference is the difference between these two. Oh man, I have not left enough room for this. 19a plus 5b plus c. Difference between these two is 37a plus 7b plus c. And the difference between these is going to be 61a plus 9b plus c. All right, still absolutely nothing in common, but we did expect that because we needed 3 iterations or 3 levels. So what is the difference between these two? Again, I'm going to take this and just subtract this. I'm going to get 12a plus 2b. Whoops, I didn't write the a. 12a plus 2b. And then the difference between these two is 18a plus 2b. And again, I'm going to get 24a plus 2b. Now this is a good sign. See how all the b's are 2? So I know in my next line they're going to disappear. Just like here, in this line here, all of them were a singular b. So of course b minus b is always 0, b minus b is 0, blah, blah, blah. So now that I've got 2b in each case, I know that I'm going to just subtract them and have them disappear. So the difference between 18a and 12a is 6a. And difference between these two is 6a. Fantastic. All right, so now we've got to an even difference. So we're going to do exactly what we did before. I know that 6a is 6, right? 6a equals 6, so a equals 1. Brilliant. And then I'm just going to go back through the stages and substitute in all of the things I know. So I know that 12a plus 2b is 4, right? So that's the next level up. So 12a plus 2b equals 4, and I know that a is 1. So 12 plus 2b equals 4. So 2b equals 4 minus 12, which is negative 8. So b is minus 4. You are definitely allowed to have negatives, no problem with that. Then I'm going to jump back another row. So I'm going to jump back to this one here. Let's jump back to there, and then we're going to say that it equals negative 2. So I'm going to say 7, what am I doing? 7a plus 3b plus c equals negative 2. Right, and then I know that a is 1, so 7, and I know that b is negative 4, so 3 times negative 4, well that means negative 12 plus c equals negative 2. So then you should just be able to tell that c is 3. Great. And then I'm going to do it one more time for d. So I'm just going to go back to this one here and say that it equals negative 6. So a plus b plus c plus d equals negative 6. So 1 plus b is negative 4 minus 4 plus 3 plus d equals negative 6. So hopefully that will tell you that d is actually negative 6. These things are all cancelling out, right? 1 minus 4 is negative 3 plus 3 is 0. So great. All right, so now that I have my 4 values, I'm going to write it like this. So the nth term is a is 1, so I've got n cubed minus 4n squared plus 3n minus 6. So that should be your final equation. Now I know this is really complicated and there are multiple ways and multiple steps that you can mess it up. The longer a question is, the more opportunity for mistakes. But I think the more we practice it, the more we're going to get it. So have a go at doing this. I know it's particularly tricky, but try and use some tables, and obviously you will need more space than me. I've done a terrible job. Either you can write smaller or you can actually turn your book sideways so you can have more space for tables. All right, get in touch if you still don't understand what on earth I'm talking about, and good luck.